By the continuation of chapter atomic structure, we are today look about the electronic configuration. In this, we have to arrange the electron on the basis of increasing energy level. And this increasing energy level, we will calculate the value of n plus L rule, which already we studied in previous class, where n stands for principal quantum number, L stands for azimuthal quantum number. And one more thing you have to remember, this is increasing energy level. Energy you will calculate by the help of principal quantum number value as well as azimuthal quantum number value. And where you will find value is same, we are taking example for 3s and 2p, you will find the value of n plus L rule. For this, principal quantum number is the coefficient is here, so it is become 3, and for s it becomes 0, right? So its value of energy is 3, right? And then we are taking care of the value of energy this level. So 2 is the principal quantum number because 2 we are finding as a coefficient, and L value for p orbital is 1, so it becomes 3. So both the places we are finding same energy level, right? In this situation we have to do where value of n is less, that is considered as lower energy level, right? In this situation, which one is 2p is lower value because n value is low in 2p, so 2p will fill first and then we will fill the 3s, right? Like this you have to be take your idea somewhere. If a confusion like energy level is same, how we will identify increasing or decreasing energy, right? Apart from that, you have to memorize one more thing where we accommodate the electron. First of all, keep in mind s orbit have maximum capacity of accommodation of electron 2, p having maximum ability of 6 electron, d having 10 electron ability to fill, and f having 14 electron ability to fill, right? And we already little discussed about in previous class, this is maximum capacity of substituting electron. Next is how we are going to be substitute electron in normal situation. First of all, you see first electron filling by 1s, right? And then you have to fill the electron in 2s, 2p, and again it become 3s and 3p. This is the increasing energy how we are writing. Then we are using this is 3d, right? Next you may write like 4s, 4p, and 4d. Finally we are writing 4f. Like this we have to use the idea. And 1s you have to fill the electron, then it is 2s, and 2p, 3s you have to come from the back side, right? And then it is comes like 3p and 4s electrons. Like this you will increase the 4s, then 5s, 5p, 5d, 5f, right? And then 6s, 6p, 6d, 7s, and 7p. We don't require too many, just to memorize the idea how we fill the electrons with increasing energy level. Or sometime you memorize the first of all we have to fill the electron in 1s, then 2s, 2p, 3s, 3p, like this. And next if you are watching, then we have to go for 3d, 4p, and 5s. If you start like this, you have to fill the electron in this increasing energy level. So memorize the idea how we going to be fill the electrons. We are starting from the simple atom like a hydrogen. Hydrogen we have to write the electronic configuration. For the hydrogen we know first we have to go for 1s. So you write like 1s here, and then you think s having how many electron capacity? Maximum 2 capacity. But hydrogen have how many electron is available? It is only 1. So you may write electronic configuration for hydrogen is 1s1, because see s capacity for accommodation of 2 electrons, but in present scenario we have availability of electron is only 1, so we are writing 1 electrons. Next we are moving for the helium, and we require to practice up to 30 number of atomic and write the all electronic configuration. Do practice. I'm doing a little practice here, but by yourself you will do practice. It makes a little perfection how you are. So this is 1s1. Now is the situation 1s2, right? See, electronic configuration. Helium having 2 electrons, we are substituted 2 electrons like 1s2. Similar, if any next electron will reach, it do not enter in 1s because 1s is completely filled to capacity. Now next is after it become 2s, 1s after 2s. So if some electron is availability, we have right here 2s and substituting electrons, right? Next we are taking example for the lithium. Lithium have 3 electrons and we are going to be writing the electrons electronic configuration. So it become 1s2 simply, and 1s2 after 1s2 which one is coming? 2s. And we know in 2s having electronic nature is maximum 2 but availability of electron is only 1, so we are writing like 2s1. Next is beryllium, is element which having atomic number is 4, and we are thinking number of electron and number of proton is same in a neutron atom. So atom having no any charges experienced on atom, that's why we are writing 4 number of electron and it become 1s2 2s2. Why 2s2? Because 2 is the maximum capacity, no more electron in that, so we don't require any location or any place where we accommodate electron because already electrons are consumed. Next is beta boron 5, where we have to write the electrons. We are writing electrons like 1s2 2s2, it already filled. Next is which one? Where we have to accommodate electrons. So see, first you will have to fill 1s, then we have done 2s. Now we start with 2p and 3s. So you may write like this. Next is boron 5 electron, 4 you had already accommodated. So now you can do, you will add 2p. And how many electron is only left? 1 electron. So you can write like this 2p1. Next situation for us, carbon. Carbon is 6 atomic number. You can write like electronic configuration of similar. It's a little easy. Currently you are thinking it's easy, but when you will do by yourself it become little harder, right? So keep in mind, be practice. In chemistry we have substitute lots of practice. On that behalf we will get a great idea in chemical science. So please, I'm requesting to everyone, don't think it is quite easy. Please be practice. Start to writing up to 30 elements and you get little exception also. Somewhere we find the exception on the steps we are finding where exception occur, and you have to memorize like this. This is very important to getting some other effective idea of this chapter. Like atomic structure, we have valence electron, valency, everything comes from here, reactivity, all that nature are coming from there. So don't be ignored, just you do practice, and practice it makes you perfect. Taking at next level 1s2, then we are writing 2s2 and then 2p2. This is electronic configuration we have, because their capacity of p is, we already discussed, capacity of p is 6 electrons, but current scenario only we have available electrons is 2, so we are substituting 2 electrons. Now we are moving ahead with this idea for nitrogen. Nitrogen have 7 electrons and we can write the electronic configuration like 1s2 2s2 and 2p3. This is our electronic configuration for nitrogen. Then next is oxygen, and you must be memorize the atomic number. It is too much required for the concept of mole concept. We had read, I think in previous lesson we read the idea of what is atomic number, atomic mass. In this frequently we are using for amount of substance presenting idea for mole and all calculation. So oxygen is 8, we are writing 1s2 2s2 and 2p4. This is electronic configuration. Simply we are writing because we know it is highest number of electron accommodation capacity of p orbital is 6. Or keep in mind, there is doesn't matter what be the coefficient is written over the suborbit, right? Because this is only gives an idea of principal quantum number. Accommodation of electron is depending upon the ability. So 1s having also 2 electron, 2s having also 2 electrons. Sometimes people are confusing if it become larger, 6s having also bit the same number of electron capacity like a 2 electrons. P orbital, if it is lower number doesn't matter, if it is higher number doesn't matter, accommodation of electron is always constant. So oxygen, then you have to take a chance for the fluorine, right? So what you will do for fluorine is 9 electron. You can write like 1s2, 2s2 and 2p5. Total number of electron you can correct it like 2 plus 2 plus 5 cross verified, total 9 electron. 9 electron is available in fluorine. Similar you can do for the neon also. Neon having 10 electrons, you can do for neon 1s2, 2s2 and 2p6, right? So it become now it is again filled. We don't require to accommodate more electrons because p having capacity of maximum 6 electron, which is already filled. So now we have to again enroll with the next level of position, like see, this is 2p you have done. Now it is turned for 3s. After 3s turn for 3p. Memorize this, 3s and then subsequent it comes 3p and then it is 4s. Like this you have to memorize. 2p you had already filled in so many experiences of question. Now it is turned up for 3s and then 3p then 4s if required, but first we are looking for only 3s. So we are enrolling the 3s. We are looking for Na is sodium, where electronic number is 11, and we are writing the electronic configuration 1s2, 2s2, 2p6 and 3s1. See, very clearly we had enrolled with the next level of energy. This is 3s1 and only one electron we got substituted in this. Why one electron? Because we all of know this having capacity of 2 electrons maximum, and next energy level is this according to our electronic fashion we had seen. Then we are going for the magnesium. Magnesium is atomic number 12. We are finding this is the electronic configuration 1s2, then 2s2, then 2p6 and 3s2. Like this you have to be fill the electrons. Magnesium. Then we are last doing for the aluminium today, and do practice, and I'm requesting to everyone, do at least up to 30, and whenever you will feel doubt, please ask me via message which electronic configuration you are unable to design. I will give an idea. Next is 1s2, 2s2, and don't ignore beta, it's not easy. When you are doing 1-2 times it become little easy, and there is too many, it's implementation, too many things you can identify from there. So see, this is the electronic configuration. Today I'm closing here. Tomorrow we start from 14 onwards. So this is our, and do lots of practice. If you have time, go for the little more number of elements which having atomic number up to 30. Thank you.